Okay, so the next trend that we are going to see is atomic size. So again, similarly, before knowing about the trend across period and across group, you have to know about, you should be knowing about what exactly is atomic size. So atomic size is the distance from the center of the nucleus. You know the structure of atom, okay? This is the nucleus, and these are the electrons which are revolving in an orbit, okay? So atomic size is the distance from the nucleus. This is the nucleus. And suppose if the last electron is present in this orbital. So it will be the distance from the nucleus to the outermost shell. And this distance will be giving you the atomic size of an atom. So if you want to know the atomic size of an atom, you have to calculate the distance from the nucleus to the electron or to the outermost shell of that particular atom, and you will get to know its atomic size. So now we have to see the trend. What will happen if the elements like when we are going across the period is this, okay? I have just written in this manner because no space was there. So when you are going from lithium to beryllium to boron to carbon across second period, we will see what will happen, and same thing will be applied to the downward periods. That is, third period may be apply hoga, fourth period may be apply hoga. Similar concept will be applied. Okay, so now you can see that this is the elements of first period. Beryllium atomic number 3, boron atomic number lithium 3, boron beryllium 4, boron 5, and so on. Okay, till oxygen I have written. So you know one thing, that nucleus is having a charge. There is some charge on nucleus which is known as nuclear charge. Okay, protons and neutrons are present here, and this nuclear charge should be equal to the electrons which are flowing in the shells, right? तभी वो उसको एक स्टेबल बनाएगा, तभी it is possible. जब तुम लोगों ने 9th standard में पढ़ा है structure of atom, you have read that number of protons should be equal to number of electrons to maintain the electrical neutrality of an atom. Okay, so whenever these electrons are revolving, how they are revolving? It is because of a force of attraction which is there between this nuclear charge and the electrons. Okay, so जो nuclear charge है, nuclear charge is putting a force of attraction. एक force of attraction होगा between nuclear charge and the outermost electrons, and because of that electrons are able to revolve in the orbit or in the shell. So you can see here across the period what is happening. When we are going in a period second में when we are going, so number of electrons are increasing, right? पहले 3 थे, फिर उसके बाद 4 हो गए, फिर 5 हो गए, फिर 6 हो गए, फिर 7 हो गए, फिर 8 हो गए. So number of electrons are increasing, okay? And if number of electron is increasing, जब number of electrons increase होंगे और atomic number increase होगा, definitely number of protons increase होंगे. And अगर number of proton increase हो रहा है तो मतलब कि protons are present in nucleus, so nuclear charge is also increasing, right or wrong? Nuclear charge is also increasing on moving from left to right across a period. So you can see here, this is first atom lithium. You can see the structure. यहाँ पे nucleus है, 2 electrons are present in K shell, 1 electron is present in outermost shell. Okay, so in this case the nuclear charge is 3. Now moving on to the next atom. Next atom है 4. तो यहाँ पे क्या होगा, 4 में nuclear charge increase हुआ. On moving to a next atom, nuclear charge has increased. And if the nuclear charge has increased, then the power of this nucleus to attract the outermost shell is also increased. इस case में it was less. In this case it is more in comparison to lithium, because यहाँ पे nucleus का charge increase हो गया. Earlier the nuclear charge was 3. Now the nuclear charge is 4. 4 protons are present. So 4 protons will more strongly attract the outermost shell. Similarly boron के case में nuclear charge और increase हो गया. Nuclear charge now is 5. And electrons are going in the same shell itself. Right? Number of shell increase नहीं हो रहा है. उसी shell में और electrons जा रहे हैं. तो ये जो nucleus है, it will attract more strongly the electrons. In the case of carbon, now more electrons are there, 6 electrons are there. So this nuclear charge has increased, and because of increased nuclear charge, it is going to attract more strongly the electrons which are present in outermost shell, and hence you can see that size is decreasing. Okay, electrostatic force, this is the, यहाँ पे मैंने फोर्स के बारे में बताया था. सो यू कैन सी इन द पिक्चर व्हेन वी आर गोइंग डाउन व्हाट इज हैपनिंग, एटॉमिक साइज इज decreasing, right? There is decrease in atomic size. And why the atomic size are decreasing? Because nuclear charge is increasing. Nuclear charge increase होगा, and more the nuclear charge, more strongly the electrons will be attracted in this last shell. Understood or not? Now we will see what happens in the case of group. Okay, simple example group 1 का ले रहे हैं because you are familiar with the group 1 elements. So first element is hydrogen, then is lithium, sodium and potassium. Okay, so now you can see here, अब जब हम ग्रुप में जा रहे हैं तो ग्रुप में क्या होता है, whenever we are moving in a group, each a new shell is being added from jumping from one element to another. Lithium था, lithium में 2 shells were there. In the case of potassium, one more shell got added and it became 2, 8, 1. In the case of potassium, again one more new shell was added, right? So what is happening when you are going down the period? When we are going down the period, what is happening? There is increase in nuclear charge. ठीक है, यहाँ पे भी nuclear charge increase हो रहा है. There is increase in nuclear charge, right? But in spite of increase in nuclear charge, what is happening? You can see that the distance from the nucleus to the outermost shell is also increasing. As the distance between the increase, as there is increase in the distance between the nucleus and the outermost orbital, outermost shell, so what is happening because of that? The electronic force of attraction or the electrostatic force of attraction between nucleus and outermost orbital is becoming less. यहाँ पे क्या होगा, सबसे less electrostatic force of attraction होगा यहाँ पे, because of the large size बड़ा है तो attraction कम हो जाएगा. सोडियम के केस में क्या है, the force of attraction will be bit more in comparison to potassium because इसका size, सोडियम का size is smaller than potassium. And in the case of lithium, सबसे छोटा size तो lithium का है इन तीनों के comparison में. तो सबसे छोटा size किसका होगा, lithium का. So whenever we are moving in a group from top to bottom, what is happening? The size is decreasing. Atomic size क्या हो रहा है, atomic size is increasing on moving from top to bottom. And why it is increasing? It is increasing because there is increase in the number of nuclear charge, but in spite of that, what is more prevalent? Increase in the number of electronic shells. Okay, यहाँ पे देखो नंबर ऑफ इलेक्ट्रॉनिक शेल्स हर लेवल में बढ़ रहे हैं और उसकी वजह से क्या हो रहा है, साइज बड़ा हो रहा है. अंडरस्टूड एवरीवन?